Hello everyone, I am back with a new video in which I will be doing the revision of trigonometric concepts for both class 9 and 10 of ICSE, CBSE and all other boards. So in this video, I am not covering the sums or the questions, but I am only tackling the basic concepts and in fact all the necessary concepts which will be useful for exam. I'll be straight to the point and without wasting any precious time, we will just get into the video now. The first topic in trigonometry is trigonometric ratios. So let me give the heading first. In order to study trigonometric ratios, we first need to draw a right angle triangle. And in this right angle triangle, which is right angled at B, that is B, angle B is 90 degree. I need we need to consider one angle out of A and C. I am considering A. So here on, we will be representing our trigonometric ratios by angle A. Okay. Let's name the right angle triangle. Let's name the parts of it. So see, opposite to the right angle means this side. The side which is opposite to the right angle is always called hypotenuse. And the side which is opposite to the angle that we have considered in trigonometric ratio, like see, there are two angles, one is C and one is A. So out of these two, I have to consider one angle. So here I am taking angle A, and opposite to angle A is the side BC, right? See, this is the angle, this one is the angle, and opposite to this is this side BC. So this side is always called perpendicular, or we can also represent it as height. So here I will be considering it as perpendicular to avoid confusion, because sometimes when we write, like suppose I'm writing B by H, so this H represents hypotenuse and not the height. So sometimes students get confused in writing H as in representing H as hypotenuse or as height. So here I will be using H as hypotenuse, B as the base, and P as the perpendicular. So I'll be writing everything, don't worry. The third side, which is BA, or better to call it as AB. So this is base. So see, I'll just revise it once again. The side which is opposite to the right angle is always called hypotenuse. The side opposite to the angle that we are considering, like either from either A or C. So if we take A, opposite side will be BC, and that is called perpendicular or height. Now the third side remains, and that is obviously become base. So in my example, I have taken A as my angle to find out all the trigonometric ratios. You can also consider C. So let's start now. The first ratio is called sine of A, or we can better call it as sine A, which is P by H. So here P is perpendicular and H is hypotenuse. This is P, which is perpendicular, and this is H, which is called hypotenuse. So in our example, perpendicular is BC. So I'll just write here BC, and hypotenuse will be CA. So see, this is perpendicular and this is hypotenuse. Now how to pronounce this? Many students pronounce it as sin A. So let me tell you that this is not sin A, this is sine A. Write the complete name. It will be SINE and then A. So we don't include this E here. So obviously this is called as sine A. Okay, so let's move ahead. The second ratio, the second ratio is cos A. Now cos is called cosine. So this is B, that is base, by again hypotenuse. So our base is AB and hypotenuse is CA. Similarly, we have the next ratio as tan A, which is better called as tangent of A, or shortly said as tan A. This is perpendicular by base. So here perpendicular is this side, which is BC, and our base is AB. So this will be BC and this is AB. Now, very interesting fact. Just see here. After writing these three ratios, we have the ratio. We have the ratios which are nothing but reciprocal of all these three primary ratios: sine, cos, and tan. So reciprocal of sine will be cosec. Reciprocal of sine will be cosec. So cosec A will be nothing but the reciprocal. Reciprocal means you have to take the numerator as the denominator and the denominator as the numerator. You just have to reverse the position. So obviously this will be hypotenuse by perpendicular is equal to CA by BC. Now the reciprocal of cos will be sec A, which is equal to hypotenuse divided by base is equal to CA divided by AB, and then the reciprocal of tan will be cot. So this will be cot A, which is equal to base divided by perpendicular is equal to AB divided by BC. Now I'll just write the full form. So this is nothing but SINE sine. This is cosine. This is nothing but tangent. So this cosec is cosecant. Cosecant. This sec is secant. SECANT. This cot is called cotangent. Now there are certain mnemonics, better to say short forms, or like a small rhyme to remember all these ratios. Okay. So there are many rhymes available on the internet. I will just tell you one or two. You can choose one of them, or you can just make your own. So the first mnemonic is: some people have curly brown hairs to present beauty. So let me read it again. Some people have curly brown hairs to present beauty. Now, what is this funny thing? I'm just marking, and once I mark, everything will be clear. So let me highlight. Okay. So see, this one, are you able to see this? The first letter S, P, and H. So see, this is S stands for the sine, P stands for perpendicular, and H stands for hypotenuse. So SPH. So this is H, this is S, this is P, this is H. So S for sine. Some people means P, that is perpendicular. H means hypotenuse. So this is done. This is for sine. Now the next one, curly brown hairs. See the first letter, this is C, this is cos, this is B, that is base, and this is H, that is hypotenuse. Now again, this is T. T means tangent or tan. Then you get P, that is perpendicular, and then you get B as base. So this is one way of learning all the trigonometric ratios. Some people have curly brown hairs to present beauty. Now the next one is a less sophisticated one. I'll just write it down for you. Just look carefully. This is Pandit, Padri, Prasad, Har Har, Bole, Sona Chandi, Tole. Tole means to measure, right? Sona Chandi already know. Tole means to measure. Okay. So just look here. Now see P here stands for perpendicular. H here stands for hypotenuse. And S here stands for sine. B here stands for the base. H here stands for the hypotenuse. And C here stands for cos. Now the next one, P here stands for perpendicular, B stands for base, and T stands for tan. There are unfortunately no mnemonics for this cosec, sec, and cot because obviously once you know all these ratios, you can just you can just do the reciprocal, and we will get all these three other remaining t ratios. Either this or this, you can follow any one of them to tackle these t ratios. No need to just mug it up. All these are not required at all. Just focus on this, or you can additionally make your own mnemonic. Okay, so let's move ahead. Okay, I just missed one thing. We can also write these t ratios as then a is equal to 1 by cosec a, means we can use these relations in the while solving questions also. Cos a is equal to 1 by sec a, and tan a is equal to 1 by cot a, and vice versa. You can just take cot a up there, and you can bring tan a here, similarly for this and similarly for this. I hope there is no problem till here. And one more thing, one very important and a basic knowledge that I want to impart is, if this angle is 90, so angle A plus angle C will be equal to 90. So angle A plus angle C will always be equal to 90. So now there may be different combinations like 45 45 or 60 30 or 30 60, like that. Okay, so let's move ahead now. There are one or two terms related to these t ratios only. Here, tan can also be written as tan A can also be written as sin A divided by cos A. Similarly, cot A be can also be written as cos A divided by sin A. We just need to keep this thing also in mind. So this was all about trigonometric ratio, better known as T ratios. Okay. So now we'll move ahead and revise trigonometric identities. So very important information for you all is, we do not need to prove any trigonometric identities for the exam purpose, but if we know how to derive them, life becomes a lot easier. Because if suppose by any chance you forget how to do these any trigonometric identity, you will be in a fix. So just look here, I'm deriving it in a very easy manner, and just by remembering the derivation, we can get all the trigonometric ratios very easily. Okay, so let's start. So again, I'll just draw a right angle triangle. This was A, this was B, and this is C. My triangle is right angled at B. So we already know what is Pythagoras theorem, right? So I'll write it down here. AC square is equal to AB square plus BC square. Divide your page into three columns. This is our main relation which I got from the Pythagoras theorem. Now, the very first thing in all these three columns, our journey starts from this very equation. Okay, this here, this will be there, and obviously this will be there. But first, we will divide this equation by AC square. Okay, so let me call it as equation 1. Okay, see, so divide equation 1 by AC square. Okay, so the result will be AC square by AC square is equal to AB square by AC square plus BC square by AC square. Okay, so AC square by AC square gets cancelled out, so we'll get 1. Then AB square by AC square, and here is BC square by AC square. So let me take you to our T ratios that we calculated. So just pay attention here, AB by AC. Okay, so let's see what is AB by AC here. Let me highlight it for all of you. See this AB by CA or AC. So this is cos A. AB by AC is cos A, but again there's a twist. This is square, so I'll have to write square plus BC by AC. Again, let's go there. BC by AC. So here it is. This is BC by AC or CA. It's all the same. So this is sine A. This is sine A. And since this is in square, so we'll write sine square A. Okay. So see, here we get our first identity. Cos square A plus sine square A is equal to 1. So if we write it in a better way, this will be sine square A plus cos square A is equal to 1. So this is our first identity. Now the second one, how we'll get? See, here we divided it by AC square, right? This is AC square. Now for number 2, we'll divide the whole equation by AB square. Okay, it's very easy. That's why I said that if we know how to derive it, it's just a matter of 2 minutes. In case we forget any identity, we can just derive it right there. So divide by AB square. So this will be AC square divided by AB square is equal to AB square divided by AB square plus BC square divided by AB square. Okay, so meanwhile, I'll just write for this for number 3 also. All the three cases will get one whole term as unity, that is 1, because of the cancelling effect. So AC square by AB square. Let's go above and check what is AC square by AB square, or better to say AC by AB. AC. Okay, just look here. This is AC or CA, right? Let me highlight this one. AC by AB. So this is for sec. The next one, BC by AB. Where is BC? This is okay. Okay, we got this BC by AB. So first it will be sec, and then it will be tan. So let's write. Okay. So here we get our next equation. Better to say next trigonometric identity, which is sec square A is equal to 1 plus tan square A. Now it's time for the third one. AC square by BC square. Okay, so this gets cancelled. So let me write 1 here. And AC square by BC square. Let's check out our T ratio. AC square by BC square. So AC by BC. Where is AC? Yeah, this one. This is CA or AC and this is BC. So it is for, as you can see, cosec A. So let's write AC by BC. AC by BC is cosec A. So this is cosec A, and then since square is given, so cosec square A is equal to AB by BC. Let's go to our trigonometric ratio again to find out what is AB by BC. I think so. Yes, AB by BC. Where is AB? Yeah, this one. So this is AB, then it will be BC. So I'll need cot A there. Let's write it down. So this is cot square A plus 1. So this was, see, I told you this is that easy, okay? To find out all the three trigonometric identities. The derivation part do not come in exam, but if we know, our life becomes easier. First, we did trigonometric ratios or T ratios. Next, we did trigonometric identities. And now we are going to do the angles. So I'll just teach you how to draw the trigonometric angles chart in a very short time, like in a matter of 10 to 15 seconds. Yes, you heard it correct. In just 10 to 15 seconds. So first I'll teach and then you all can practice and you'll never make mistakes again. This chart has been drawn for specific angles which are considered as the main angles for the T ratios. Okay, let me write the heading first. It will start from 0 degree, then we'll move to 30 degree, then we'll move to 45 degree, then we'll move to 60 degree, and the last will be 90 degree. Let's write degree also here. And now on the very left side, we will write all the angles, or better to say the T ratios. This will be sine A, or so see what is A here. This A is 0 degree, okay? So in this place, this A is 30 degree. Here A is 45 degree. So here A will be 60 degree, and here the value will be sine A. Or see, this A will be 90 degree. So in this box, we will be writing the value of sine 90. In this box, we'll be writing the value of sine 60, like that, okay? Instead of taking A, I can also take theta. Okay, this is called theta. It also represents the angle. Then we'll write cos A. Then it will be tan A. Then reciprocal of sine A, that is cosec A. Then sec A. And last, it will be cot A. In order to start our journey, the value of 0, that is the sine 0, will always be 0. So we'll start our journey by 0 only. So sine A, this is sine A, this is 0 degree. It means sine of 0, right? Just replace A with 0. Sine 0 will be 0. The journey starts from A, right? So it will be starting from 0 and it will end at 1. So the value will always be ranging from 0 to 1. So sine of 0 will be 0, sine of 90 will be 1. So all the values will come in between this only. So sine 0 is 0, sine 90 is 1, and after 0, at 30, half distance is covered. That is, in order to go from 0 to 1, half of the distance is covered. So 0, then this becomes half. Now, once you write half here, we need to decorate it. Yes, you heard it correct. Just learn it as I am saying. This is 0, this is 1, half of the distance is covered. Then we need to decorate it one by one. So what do you mean by decoration? So see, this 2 will be decorated. The decoration in maths is just adding a square root. Okay. So this 2 becomes root 2. And now this 1 is also saying that why did you leave me like that? So see, if we decorate 1 by adding the square root, the value will be 1 only. So there's no use. So instead of decorating 1 by square root, we just take another number here. That is 3. Why 3? 1 is done, 2 is done. The very next number is 3. So see, there is no logic here. Okay. This is just a small story that I made for myself to learn this whole table. Since I'm explaining it to you, this is taking this much time. Once you get all these in your head, It's just a matter of 10 to 20 seconds, and yes, you'll be able to copy this table very quickly in your answer sheet. So this becomes root 3, and from here we'll get 2. I'm repeating, we'll start the journey from 0, we'll end it to 1. Going to the next value, half of the distance is covered. Now, out of these two numbers, they are saying to decorate them. We will decorate 2 by adding root 2. Now 1 is also saying that why didn't you decorate me? Now for the next value, that is for this value, you need to decorate me also. So if we decorate it, if we write square root of 1, there is no use because we will get 1 only. So we'll just write the next number after 1 and 2, that is 3. So we'll just decorate 3 by adding the square root, and this will be divided by 2, right? Now let's move ahead. For writing the values of cos A, we have to write all these values in reverse order, which means 1 we'll be writing 1 here. This root 3 by 2, we'll be writing it here. This 1 by root 2 will be at this place only. 1 by 2 will come here, and this 0 will come here. So see, it's that easy. This value comes here, this value comes here, this remains at this place only. This 1 by 2 comes here, and this 0 comes there. Now, tan. In order to write tan, we need to divide sine by cos. So sine A by cos A. So just divide the values, okay? So see, 0 by 1. What will be 0 by 1? 0 by 1 is 0. What is 1 by 2? Divide by root 3 by 2. This 2 gets cancelled. So the value will be 1 by root 3. Again, for tan 45 degree, 1 by root 2 divided by 1 by root 2, which is equal to 1. Then root 3 by 2 divide by. So see, this is divide by 1 by 2. This 2 and this 2 gets cancelled. So the value which will be written here as root 3. You can also write it as 1 by 1, root 3 by 1. Okay. Then 1 by 0. Now see, this is very important. 0 by any number. Okay. 0 by any number is always equal to 0. But any number divided by 0 is always equal to infinity or not defined. Just remember this. Okay. So here 1 divided by 0 means sine by cos. 1 divided by 0 is nothing but infinity or not defined. The next set of angles will be for cosec, sec and cot. Now this is very easy. What is cosec? Cosec is nothing but 1 by sine A, right? So just write the values by doing reciprocal. So this is 0. 0 means 0 by 1, okay? 0 by 1, the reciprocal of 0 by 1 will be 1 by 0. Again, I just mentioned here, anything divided by 0 will be not defined. So 1 by 0 will be not defined. Infinity. Now this value here will be 1 by 2, the reciprocal, which means 2. Then 1 by root 2, the reciprocal will be just root 2. Root 3 by 2, the reciprocal will be 2 divided by root 3. This 1 by 1 will be 1 only. Sec will be the reciprocal of cos. So this will be 1 by cos A. 1 by 1 which will be 1. Then root 3 by 2. Root 3 by 2 will become 2 by root 3. 1 by root 2 will become 2. 1 by 2 will become 2. And 0 by 1. See, 0 by 1 will become 1 by 0, which is not defined. Now again, we can just establish a relationship between these, starting the journey starting from infinity till 1. And then in for sec, it is in reverse order. 1 comes here, 2 by root 3 comes here, root 2 remains at that place only, 2 goes there, and infinity goes there. Okay. Now cot is nothing but reciprocal of tan. It is 1 by tan A, or we can say it as cos A divided by sine A, right? So the value of cot will be this is 0 by 1. So the reverse or the reciprocal will be 1 by 0. That is not defined. This will be 1 by root 3. Reciprocal of 1 by root 3 will be root 3. This 1 will come here as 1 only. And root 3 by 1 will become 1 by root 3. And the last, this is infinity. So see, what is infinity? 1 by 0. So reciprocal of 1 by 0 will be 0 by 1, 0 by 1, which is nothing but 0 only. So this is all about the chart of trigonometric angles. If you know how to make the chart, I always suggest to my students that once your writing time is started, within 1 minute, just write all the trigonometric identities, those three identities, 1, 2, and 3. Okay, then just draw a trigonometric table where you write 0 here, 30 here, 45 here, 60 here, and 90 here. And this will be sine, this will be cos, this will be tan. Then write cosec, sec, and cot. And just copy all the angles. The journey starts from 0 to 1, that's the same story. And you just complete this and this. It take hardly 1 to 2 minutes, and just like write all both of these things, and you are sorted for the trigonometric part. Okay, so let's move ahead. This is the last part of the revision video. This is called trigonometric ratios of complementary angles. First thing is, what are complementary angles? Complementary angles are nothing but the sum of two angles must be equal to 90 degree. Okay, A plus B must be equal to 90 degree. Let's jump into the ratios for the complementary angles itself. So the very first angle will be sine of 90 minus A. This will be equal to cos A. Okay, so see what is happening here. This sine changes into cos in the presence of this angle. Okay, so while doing the questions, if we need to change sine into cos, we need to make changes in the angles, and 90 minus, after doing 90 minus A, we'll get cos A. For example, sine 55 degree will be equal to cos 35 degree. How? Just see. This is sine. And see, how did we get this 55? Just equate it here. This is 90 minus A. So 90 minus 35 degree. Right? After doing 90 minus 35, we get 55. So by this identity, just check this out. See, this is sine. This is sine. This is 90. Here I've written 90 minus A. So minus 35. Okay. So here will be cos A. So this see, just see this cos, and here A, what is A? This is A, that is 35. Okay. So how to think in these type of questions? The best idea to save yourself from any confusion is just think that how this 55 came here. So how did we get 55? Okay, we got 55 by 90 minus 35. So this 35 becomes our A. That's all. Next one is very easy. Just replace the sine by cos. Okay, so this will be cos of 90 minus A. This will be sine A. So see, the relation of sine and cos is done. Okay, so after sine and cos, we will have the same relation between cosec and sec. Cosec of 90 minus A becomes sec A. Sec of 90 minus A becomes cosec A. So see, now sine, cos, cosec and sec is done. What's left? Tan and cot. So tan of 90 minus A becomes cot A. Cot of 90 minus A becomes tan A. So this was all about the revision part. I can show this thing in the table itself. In order to take another example for you to understand, let's consider A is equal to 30 degrees. Okay. So now deal with this. Sec of 90 minus 30. So sec of 90 minus 30. Here 30 is A. So sec changes to cosec. So we'll write cosec, and this will be 30 degree. Finally, we can write as the value of sec 60 degree will be equal to cosec 30 degree. Let's check in the table. This is cosec 30. Cosec 30 is 2, and sec 60 is 2. Proved. See, sec 60 is equal to cosec 30. So that was all about this revision video. Thank you for listening.